Mr. M presents Collecting Data. Or is it data? I say data. Okay. Hello, mathematicians. In this video, we're going to talk about the concept of data and how we collect it, how we display it, and what it really is. Data is basically information. More specifically, it's little pieces of facts and measurable details that go to make up what we consider information. There's a lot of ways that we can collect data. Sometimes we use things like surveys. There's a lot of ways that we can display it, often through a graph of some kind. Either way, it's never been more important for you to understand data. Right now, governments, organizations, businesses, they're collecting data about you. They want to know everything from your age to how you like to spend your money. For businesses, data is important to help them design products that you might need and want to buy. For governments, data is important to keep the country secure and powerful. No matter what, it's never been more important for you to understand how data is used to convince you of things. It can be used to make a point or an argument. You need to understand what is good data and what is data that is biased that you can't trust. There are two main types of data that we look at. The first is called primary data. Just like the name sounds, primary data is the first stop for data. It's where data becomes part of information. So for example, in this picture right here, this woman is conducting a survey. She's speaking to this woman here. She is getting information from this woman directly from her, directly from the source, and recording it. She's collecting the data straight from where it comes from, that individual person. She'll then take that later and make what we'll call secondary data. Over here we see an online survey. Online surveys work the same way. Someone sets them up and you fill out the information specifically and directly onto the computer. You're giving them the information from your head right to them. That's primary data because they're collecting it straight from the source. Secondary data is primary data that someone has taken and interpreted and then given to you. So for example, in this case, we see an infographic that talks about the amounts of money that people make working at different donut shops across Canada. Someone has taken the time to call these donut shops, ask them what their hourly wage is, and then put them together in a way that you can make a comparison by looking at them. The primary data was when someone called the Tim Hortons in Prince George and asked how much they made, and called the Robbins Donuts in Newfoundland and Labrador and asked how much they made. The secondary data was when they put it all together in an infographic for you to see. A really common place for you to find secondary data is in the media. So for example, newspapers like this gentleman is reading, videos on YouTube, news broadcasts, magazines, websites. Most of those hand you secondary data that someone has taken and interpreted. So why would media interpret the data for you? Well, typically, types of media have some sort of a point that they want to make. And if they give you the individual pieces of primary data, it's going to fall on you to make the connections and make your own decisions. If they put it together for you, then they can advance their argument. That's where the power in data is. Whoever interprets it gets to set what the meaning is. And often data can be interpreted in many different ways. That's why it's really crucial that you are able to see through secondary data and actually interpret primary data for yourself. Hopefully that will help you see through arguments that seem appropriate, but when you examine the primary data behind them, they're actually faulty and maybe misleading. When you're working with data, there's a number of key concepts that you need to understand. One of those is frequency. Frequency is just like it sounds. It's actually a measurement of how often something happens. So in the case of data, it's how often do you see a certain outcome for the number of times that you actually look. So we're going to look at the NBA teams. When I'm measuring frequency, I want to know how much of something there is out of how many possibilities there are. Sounds a little confusing, so let's do an example. In the NBA, a lot of the teams have a name that is of an animal. So, for example, the Milwaukee Bucks, the buck being a male deer. So what we're going to look at is how many NBA teams have an animal as the name of their team. So the first thing we have to figure out is how many NBA teams are there altogether. So we need to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So that we know that how we're going to measure our frequency is out of 30. And that's going to look like a fraction, because it is going to be a fraction. A certain fraction out of the 30 teams is going to have animals as their name, and that'll be our frequency. So we already said the Milwaukee Bucks do, the Minnesota Timberwolves do, the Charlotte Hornets do, the Chicago Bulls do, the Atlanta Hawks do. None in that row. The New Orleans Pelicans do, the Toronto Raptors do, the Dallas Mavericks do, the Memphis Grizzlies do, and that's it. So let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, the Dallas Mavericks have a horse in their picture. A maverick isn't really an animal, but we're going to count it here because of the image. So 9 out of the 30 teams have an animal in their name or part of their main logo. So there's our frequency. If someone said, what's the frequency of NBA teams with an animal in their logo? I could say it's 9 out of 30. Or I could figure out the percentage. In this case, the percentage is approximately 30%, give or take. So that's my frequency. The frequency of teams in the NBA that have an animal in their logo is 30%. And if I understand frequency, I know that the closer I get to 100%, the more often something happens. The closer I get to 0, the less often something happens. So it's not really frequent that the NBA has teams with animals in their logo. But it's not quite near 0. It's a reasonably substantial amount. Another thing we need to understand when we're working with data is just how much data do we have and where does it come from? So take a look. Here we have the Lebanon High School senior class of 1959 to 1960. Okay, a long time ago, a group of students. They are together a population. They're the entire senior class of their high school. Now, they're only a part of their high school, but they are one whole group, so we can consider them like a population. If I were to ask a question to these 3 people right here on the side, these 3 ladies right here, about their entire class, I want you to think, would that be a fair way for me to decide something for their class? So let me give you an example. Let's say I asked those 3 girls what songs they would want to play at their senior end of the year dance, their graduation. And they got to decide for the entire class. I just asked the 3 of them. Do you think that that would be a fair way to choose? Or do you think it's possible that these 3 young ladies might make choices that a lot of the students wouldn't like? That's something you have to consider when you ask information from people. Now, even more concerning is, what if these 3 ladies were making a decision for the entire school, not just for the population of their class, but for the whole population of the school, in which case they would be a tiny sample. So these are things we have to look at when we're looking at data. Is it fair for 3 people, no matter who they are, to make decisions or provide information about a large group? Can looking at those 3 people tell me what this person right here or this person right here would be interested in? You need to think about that logically. So let's take a look at a real-life sampling. This is a poll for the upcoming federal election in Canada. It was completed earlier in the fall. And if you look carefully, they have to tell you what the sample that they used was. They used 1,082 random telephone interviews. What they mean by that is they called 1,082 people from across Canada at random. You can do that with computers that generate random names, right? And they interviewed those people and asked them who they thought they would vote for in the upcoming election. Now, there are some good things about this sampling, and there are some negative things. One good thing is that it was random. So they didn't pick people all from one province, for example, or one city, or from one area in a city. And in all likelihood, it means they didn't pick all men, or all women, or all older people, or all younger people. They probably picked a random sampling of people. On the other hand, somebody might say, well, only certain people are around in the evening where they can take those phone calls. Some people work at nights and maybe wouldn't be able to take those calls at all. So it would be really hard to say what type of people made these phone call interviews. The other problem with the sampling is they only asked 1,082 people. Seems like a lot, right? But if you think about it, 1,082 people out of the 30 million plus people that are in Canada, even though all those people can't vote, we can still think about them as a population, is not a very big percent of Canada. In fact, if you do a quick calculation, it is 0.00003% of Canada. It's not even close to 1% of the population. Never mind the large percentage that we're going to need to vote to actually do it. Now, why would a poll company use such a small percentage of people, such a small population? Well, think about it. This is costing them money. Elections cost tens of millions of dollars when we actually run them for the entire country of Canada. This poll company could never spend the money they needed to ask all the people in Canada. So they just ask a small section, and they hope that the fact that it's random means that it gives a good glimpse of what people think. But when you think about it being such a small sample, it's hard to put too much faith in what these numbers mean right now. That's why when we have an election, everybody gets to vote. Well, not everybody. The whole population doesn't. Obviously, there's a large chunk of people who are too young to vote, those under 18. There are a large number of people who are too ill to vote. And there are a number of people who can't vote for whatever reason. There are also a number of people who it's not legal for them to vote, people who don't have full citizenship, or people who are in prison. But we still have a large proportion of our population that is at least allowed to vote. Sadly, not all of them do vote. In fact, sometimes the percentage is less than half. But they are legally allowed to do so. So this is our population, the whole country. Samples, as we saw before, are when you take a small piece of a population and you try to make a decision based on them. Sometimes you have to, but when it comes to something as important as the actual election, they can't afford to just pick a few random people and see what they do. They let everyone have a chance. And if people want to take a chance, then the entire population is able to vote. So let's see if this has made sense to you so far. I'm going to give you a scenario here, and I'm going to ask you 3 questions about it. And thinking about what we just discussed, I want you to take a look back and think to yourself, was this a sample or a census of a whole population? Was this primary or secondary data being collected? And would you consider this survey to be biased or unbiased? So what I'll do is we'll read this scenario, we'll talk very briefly about our selections, we'll pause the video, you can circle your choices, and then I'll come back and we can decide together. So the survey says, Mr. M asked 3 grade 7 students. You should always keep in mind the numbers. 3 grade 7 students to survey the grade 7s and 8s to see what snacks the school should sell for Snack Attack. So I sent out 3 students to survey all the grade 7s and 8s to see what snacks the school, the whole school, should sell for Snack Attack. So the first question you have to think about is this a sample or a census? Did I ask a small group of people in the whole population, or did I ask the whole population? If I asked a small group of people, that's a sample. If I asked the whole population, that's a census. Is the data the students are collecting primary or secondary? If they're taking the data for the first time, it's primary. If they're taking the data from someone who's already put it together and interpreted it for them, then it's secondary. And finally, maybe the most tricky, is this going to be a biased or unbiased survey? Will the survey reflect the whole population of the school, or will it reflect another group more than the rest? If it reflects the whole population, then you know it's an unbiased survey. If it has a favoritism towards a certain group, then you know that it's biased. Let's pause, and then we'll talk about it when you've made your decisions. Okay, let's see what you think. First thing I asked, is this going to be a sample or a census? Now, the students asked all the grade 7s and 8s, but they asked them a question about something that would affect the entire school. So in this case, the population is the whole school. So it can't be a census because they didn't actually ask the entire school. They only asked a sample. They just asked 2 grades of all the grades that make up the school. So it's definitely a sample, not a census. So now, should we consider the data primary or secondary? The students the 3 grade 7 students are going to ask the individual students about their thoughts. So they're taking individual pieces of data. Later, they're going to give them to me, and maybe we'll put them together and we'll form secondary data that we share with the office or whoever is in charge of Snack Attack. But in that moment, the data that those students are collecting has got to be considered primary because it's coming right from the source. It isn't being interpreted by anyone yet. It's being collected, and that makes it primary data. And then the final question is it biased or unbiased? Well, I bet you grade 7s and 8s would say it's unbiased because they're asking everybody in their grade. But what they might not be thinking about is, once again, this is data that will affect the entire school. So why should the grade 7s and 8s be the only people that get to have a say in what is done for the entire school? If they were doing something about their area of the schoolyard or a program that's only available to them, then maybe it would be considered unbiased. But what's happening is you're giving the grade 7s and 8s preference over the entire rest of the school in making a decision that's for the rest of the school, so that data is definitely going to be at least a little bit biased. So as you can see, when you're looking at a survey or a real-life situation like that, you should be thinking to yourself, is it a sample or a census? Is the data going to be primary or secondary? And most importantly, is it going to be biased or unbiased? It's going to fall to you to make wise decisions about the data that gets shown to you. If you can't look critically at the data that's being shown to you, then it's going to make you an easy person to trick or manipulate. So make sure you take time to examine the information that's given to you in the form of data and figure out just where did it come from, and is it really saying what someone says it's saying.